Mid-February 1943. The scorched, unforgiving expanse of the Tunisian desert. The dust of the Battle of Sidi Bouzid had barely begun to settle when a strange, cast-hole silhouette appeared through the heat haze. It was an M4 Sherman, a machine that, until this moment, many German tankers had only seen in grainy intelligence briefings. This particular vehicle, however, was no longer a distant threat. It ground to a shuddering halt in the shifting sands, its engine falling silent. On its hull, the hand-painted name War Daddy 2 stood out against the olive drab paint, a defiant piece of American bravado. But the tides of the Desert War were fickle. A stark, black-and-white German Balkan cross had been hastily slapped over the white American stars, marking it as the property of the Third Reich. The men approaching the vehicle weren't ordinary soldiers. They were specialists and officers from the Schwere Panzerabteilung 501, the elite 501 1st Heavy Panzer Battalion. These were the men who operated the legendary Tiger I, the most feared armored vehicle on the planet. They were a group defined by a culture of technical elitism, accustomed to the raw power and terrifying complexity of German heavy engineering. But as they circled War Daddy 2, notebooks in hand and measuring tapes ready, their initial curiosity began to morph into something far more unsettling. They weren't just looking at a captured enemy asset, they were looking at a technological revelation. History often remembers the Sherman as a mediocre tank that won through sheer numbers, but the engineers of the Wehrmacht were about to discover a different truth. Captured entirely intact and fully operational, War Daddy 2 represented a fundamental shift in the philosophy of war. For years, the German High Command had obsessed over the big two of armored combat, superior firepower and impenetrable armor thickness. They had built land crocodiles, massive, slow, and mechanically fragile monsters. The Sherman, however, was built on a third invisible pillar that the Germans had never truly prioritized: automotive excellence. As the technical teams began their initial inspection, they realized that the mathematics of the Eastern and African fronts were about to be rewritten. The lesson wouldn't come from a bigger gun or a thicker plate of steel. Instead, it would come from a transmission that shifted with the ease of a luxury car, an engine that refused to overheat in the Saharan sun, and a suspension system that thrived under conditions that would have sheared the final drives off a Panther. This single American tank was about to trigger a crisis of confidence within the heart of the German military-industrial complex. As War Daddy 2 began its long journey from the Tunisian dunes to the top-secret testing facilities at Kummersdorf, it carried with it a terrifying message for the Reich. Germany might be building the most formidable weapons in the world, but America was building the most formidable war machine. The era of the unbreakable tank had arrived, and for the German engineers standing in the dust of Sidi Bouzid, the realization was beginning to sink in. They were fundamentally unprepared for the industrial juggernaut that was now at their doorstep.
The vehicle in question was more than just a steel box. It was a physical manifestation of the American industrial heartland. Identified by its serial number USA 306-67641, War Daddy 2 had begun its life thousands of miles away at the Lima Locomotive Works in Ohio. It was a product of a factory accustomed to building massive, heavy-duty steam engines, machines designed to run for decades with relentless reliability. This pedigree was woven into the very DNA of the tank. Belonging to Company G of the 1st Armored Regiment, 1st Armored Division, it had survived the chaotic furnace of the Tunisian campaign, only to fall into the hands of a German reconnaissance unit. Now, the Germans faced a logistical challenge: how to transport this massive prize to the coast. Instead of waiting for a heavy-duty trailer that might never come, the decision was made to do the unthinkable: drive it. What followed was a 350-kilometer trek across some of the most punishing terrain on Earth. The route to the port of Sfax was a gauntlet of jagged rocks, fine, abrasive desert silt, and temperatures that could cook a man inside a steel hull. To the German reconnaissance crews, this was expected to be a journey of constant frustration. They were used to the diva-like behavior of their own panzers, machines that required a team of specialized mechanics and a mountain of spare parts just to survive a weekend march. They set off with toolkits at the ready, fully expecting the American sofa, as they sometimes mocked it, to throw a track, seize a bearing, or burst a radiator within the first 50 miles. But the 350-kilometer journey turned into a 4.5-day masterclass in automotive engineering. As the sun beat down on the olive-drab hull, every kilometer traveled shattered a long-held German assumption about American inferiority. The Continental R975 radial engine, an aircraft-derived power plant, roared with a rhythmic, healthy thrum that never faltered. While a German Maybach engine might have begun to vomit steam or leak oil under such sustained stress, the Sherman's cooling system remained perfectly regulated. Even more shocking to the German drivers was the transmission and the final drives. In the world of the Wehrmacht, the final drive was the Achilles heel of armored warfare. On a Panther or a Tiger, the final drives were often stressed to the point of catastrophic failure. A sharp turn on heavy ground could snap them like glass. Yet the Sherman's drivetrain performed with what the Germans described as boring consistency. There was no grinding of gears, no slipping of the clutch, and no mechanical whining. The transmission shifted with a fluid precision that seemed impossible for a 30-ton war machine. The German crews watched in a state of growing professional unease. They were witnessing a vehicle that required no babying, no specialized gear-sinking techniques, and no constant mid-march repairs. It simply worked. It worked when the sand got into the filters. It worked when the terrain turned into a boulder-strewn nightmare. It worked without complaint. For the Germans, who viewed mechanical failure as an inevitable tax on combat operations, this mechanical immunity was terrifying. By the time the dust-covered War Daddy II rolled into the port of Sfax, it had completed a journey that would have sent many German tanks back to the maintenance depot for a total overhaul. Word of this performance reached the highest levels of the Heereswaffenamt, the Army Weapons Office. Realizing they had captured a specimen of profound importance, the HWA issued a Priority 1 directive. This wasn't just a captured tank anymore, it was an intelligence asset of the highest order. The orders were explicit. War Daddy II was to be loaded on a secure transport ship bound for the heart of the Reich. It had to reach the Kummersdorf proving grounds in the exact state it finished its march, intact, operational, and ready for the most brutal forensic examination German engineering could devise. The engineers in Berlin were waiting, notebooks ready, unaware that this American machine was about to hold up a mirror to the fatal flaws of the German Panzer program.
Spring 1943, the Brandenburg countryside, Germany. Under a pale, thinning Prussian sun, a heavy transport railcar hissed to a stop at the Kummersdorf proving grounds. Located just 25 kilometers south of Berlin, Kummersdorf was the high temple of German technical intelligence, the Area 51 of the Wehrmacht. It was here that the most advanced weapons of the Reich were birthed, and it was here that captured Allied technology was subjected to a cold forensic autopsy. As the steam cleared, the American intruder was revealed. To the men of the Heereswaffenamt, the name War Daddy II was nothing more than a crude souvenir of a fading campaign. They systematically stripped the vehicle of its American identity. It was officially recatalogued as Beutepanzer 259, Captured Tank 259, and fitted with the German Wehrmacht license plate WH058941. Stenciled across its hull were precise markings indicating armor thickness and angle measurements, turning the battle-hardened veteran into a living technical blueprint. Awaiting the tank was an assembly of Germany's finest scientific minds, metallurgists from Krupp, automotive designers from Daimler-Benz, and engineers from Mann and Henschel. They didn't just want to see how the Sherman drove, they wanted to dissect the very philosophy of its existence. The revelation of the powertrain. The initial teardown of the Sherman's drivetrain produced a silence of pure professional shock. The focal point of this disbelief was the powertrain, specifically the transmission gears. In the German design school, the pursuit of performance meant using straight-cut gears. These gears were theoretically efficient, but required microscopic tolerances and immense industrial precision. They were loud, they generated massive heat, and they were brittle. If a gear was off by a fraction of a millimeter, or if the driver lacked the feeling for the machine, the entire transmission would shred itself into scrap metal. To the Germans, this was the price of superior engineering, a price that demanded a workforce of master craftsmen and a nation of specialist mechanics. Then they opened the Sherman's transmission and found herringbone gears, double helical gears. To the specialists from ZF Friedrichshafen, this was a slap in the face. Herringbone gears were a masterpiece of physics. They were self-centering, virtually silent, and distributed mechanical stress across multiple teeth simultaneously, making them nearly impossible to break under normal combat conditions.
For years, German designers had dismissed herringbone gears as industrially impossible for mass production. They believed the complex machining required to create the V shape of the gear teeth was too time-consuming and required specialized milling machines that Germany simply couldn't spare. Yet, here it was. The Americans hadn't just mastered the impossible, they had standardized it. Industrial maturity versus technical elitism. The German engineers realized with a growing sense of dread that they weren't looking at a cheap tank, but a mature one. The Sherman's gears hadn't been painstakingly hand-filed by a master watchmaker. In essence, they had been churned out on automated assembly lines in Detroit and Ohio by workers who 6 months prior might have been baking bread or sewing clothes. The Sherman's design accepted a profound truth that the Germans had ignored. In total war, the machine must serve the soldier, not the other way around. Where German tanks were works of art that required a curator to keep them running, the Sherman was an industrial appliance. It was built using the principles of the American civilian automotive industry, the same principles that had put a car in every American driveway, while the German worker was still riding a bicycle. The Germans had prioritized theoretical maximums, the thickest armor, the highest velocity gun, while the Americans had prioritized the sustained output of violence. As the teams at Kummersdorf meticulously measured every clearance and photographed every bolt, the conclusion was beginning to form, though few dared to say it aloud. The Americans hadn't just built a better transmission, they had built a better way of making war. The Panzer 259 was living proof that American mass production had achieved a level of sophistication that German precision engineering simply could not match.
With the static inspections complete, the German engineers moved to the most brutal phase of the evaluation, the automotive endurance trials. At Kummersdorf, this meant the torture tracks, a series of specialized obstacle courses designed to break a machine's will. There were deep peat bogs, vertical concrete steps, and their observation towers with stopwatches and thermal sensors, expecting the American Panzer to falter where their own heavy armor often struggled. They measured everything: fuel consumption per kilometer, thermal signatures of the engine deck under load, and the microscopic wear patterns on the gear teeth after every run. The haunting discovery: operational endurance. As the weeks of testing bled into months, the data began to paint a picture that was nothing short of haunting for the German observers. When they looked at the big two of tank design, firepower and protection, the Sherman was merely adequate. Its 75mm gun could not match the long-range lethality of a Panther's 75mm KWK-42, and its armor could be pierced by standard German anti-tank weapons at moderate ranges. But in the third, often ignored metric, operational endurance, the Sherman didn't just perform, it dominated. In the German tactical manual, a Panzer was a sprint weapon, deadly in the moment of battle, but requiring hours of recovery and maintenance for every hour of movement. The Sherman, they realized, was a marathon runner. It possessed a mechanical stamina that seemed almost supernatural to crews accustomed to the fragile, high-strung nature of the Tiger and Panther. The heart of the beast, the Continental R975. The centerpiece of this reliability was the Continental R975 radial engine. Originally an aircraft power plant, it was built to sustain high RPMs for hours on end without the luxury of a mechanic standing by. To the Germans, who relied on complex liquid-cooled Maybach V12s, the air-cooled American radio was a masterclass in foolproof design. Thermal resilience. While German engines were notorious for overheating, often bursting into flames during steep climbs or in muddy terrain, the Sherman's cooling system was simple, robust, and effectively unkillable. It maintained a steady operating temperature whether it was idling in a Brandenburg spring or redlining up a shale slope. The filtration victory. Perhaps most impressive was the air filtration. German panzers in Russia and Africa were frequently crippled by dust ingestion, where fine grit would bypass the filters and grind the cylinder walls to dust. The Sherman's multi-stage filtration system handled the abrasive silt of the Kummersdorf tracks with contemptuous ease. A tank for the citizen soldier. The most profound revelation, however, wasn't a part. It was the interface. German tank design assumed that the driver would be a highly trained technician soldier, a specialist who had spent months learning the delicate art of double-clutching a non-synchronized transmission and managing a temperamental engine. The Sherman rejected this elitism. It featured a synchronized transmission for gears 2 through 5. This meant that an American farm boy with 2 weeks of training could shift gears as smoothly as a professional driver. In a Panther, a single crunch of the gears or a missed shift under the stress of combat could strip the transmission and turn a 45-ton tank into a stationary pillbox. In a Sherman, a mechanical margin for error was massive. The German testers wrote in their reports with a mix of admiration and dread. The Sherman was as easy to operate as a citizen Buick. This was the automotive democracy of the United States. While Germany was building high-performance, fragile prototypes that required a master's degree to operate, America was mass-producing combat appliances that worked every time for every soldier in every environment.
By the end of the trials, the conclusion was inescapable. The German army was fighting a war with exquisite clocks, while the Americans were fighting with indestructible sledgehammers.
June 1943, the Hillersleben Artillery Range. This was not merely a testing site. It was the proving ground for the Third Reich's ego. Under the vast, watchful sky of Saxony-Anhalt, a high-stakes demonstration was organized for the most powerful man in the German industrial machine, Albert Speer, the Reich's Minister of Armaments and War Production. Speer had been tasked by Hitler himself to deliver miracle weapons that would turn the tide of the war. He arrived at Hillersleben surrounded by a phalanx of high-ranking Wehrmacht generals, industrial titans from Krupp and Porsche, and nervous engineers. They were there to witness a display of German technical superiority. But waiting for them on the track was an uninvited guest, the dust-worn, olive-drab War Daddy II. The Sherman was lined up against the absolute pinnacle of German heavy armor, machines that were supposed to make the American M4 obsolete before it even reached the battlefield. The Panther D, Germany's brand-new sleek answer to the Soviet T-34, packed with the latest suspension and a high-velocity 75mm gun. The Ferdinand, a 65-ton monstrous tank destroyer, a brainchild of Ferdinand Porsche, featuring a revolutionary and incredibly complex gasoline-electric drive system. The test was deceptively simple, a steep gradient hill climb designed to test raw torque, traction, and the reliability of the powertrain under maximum stress. The Sherman's effortless ascent. War Daddy II was the first to face the slope. As the driver engaged the first gear of the synchronized 5-speed transmission, the Continental R975 radial engine let out a rhythmic, throaty roar. To the German observers, the tank looked tall and clunky, but as it hit the incline, its performance was a revelation. Because the Sherman's transmission was synchronized, the driver could shift gears with fluid precision, maintaining the engine's sweet spot of torque without losing momentum. There was no grinding, no coughing, and no black smoke. The Sherman crested the ridge smoothly, its engine humming with a mechanical health that seemed almost insulting to the spectators. It didn't just climb the hill, it conquered it with the nonchalance of a civilian tractor on a Kansas farm. The Panther's strained success. Next came the Panther. The 700-horsepower Maybach HL230 engine screamed as the driver pushed the 45-ton vehicle toward the slope. On paper, the Panther was the superior machine, but on the hill, the reality was more complicated. The Panther matched the Sherman's speed, but the strain was visible. The driver had to wrestle with a complex, non-synchronized gearbox. A single mistimed shift would have sent the tank rolling backwards or stalled the engine. The sound of the Maybach was not a hum, but a tortured howl. While it reached the top, the engineers noticed the telltale smell of scorched oil and the shimmering heat waves radiating from an engine deck that was already approaching its thermal limit. It was a success, but it was a fragile one. The Ferdinand's catastrophic failure. Then the behemoth moved forward. The Ferdinand was a marvel of theoretical science, utilizing twin engines to power electric generators that turned the tracks, a system decades ahead of its time. But as the 65-ton giant hit the steep gradient, the complexity trap snapped shut. Halfway up the incline, the electric motors groaned under the impossible weight. There was a sudden, sickening silence as the engine stalled. Smoke began to curl from the rear vents. The smell of ozone and burning electrical insulation wafted over the observation deck. The invincible Ferdinand sat dead on the slope, a paralyzed mountain of steel. The silence that followed was deafening. Speer watched as heavy recovery crews using multiple prime movers struggled to tow the embarrassed giant off the track. The most sophisticated tank destroyer in the world had been defeated by a simple hill. Speer's cold realization. In that moment, the propaganda of German technical superiority collided with the reality of American automotive excellence. Albert Speer remained silent as he watched the recovery operation, but the seed of doubt had been planted. Years later, in the quiet of his cell or the writing of his memoirs, Speer would reflect on the Sherman with a haunting respect. He noted that reports from the Italian front in 1944 confirmed what he had glimpsed at Hillersleben, that the Sherman possessed a power-to-weight ratio and a cross-country mobility that German experts had deemed impossible for a tank. He realized that while Germany was building technological wonders that were too heavy to move and too complex to fix, the Americans were building tanks that could climb mountains, cross deserts, and most importantly, keep moving until they reached Berlin. The showdown at Hillersleben wasn't just a test of engines, it was the moment the leadership of the Third Reich realized they were being out-engineered by the very auto culture they had so long despised.
By the sweltering summer of 1943, the technical dossiers piling up at the Kummersdorf and Harris-Waffenamt offices had reached a critical mass.
The data was no longer just anecdotal. It was an undeniable statistical indictment of the German Panzer program. While the propaganda reels of Die Deutsche Wochenschau continued to show invincible Tiger tanks crushing all before them, the internal reports told a much darker story. The reliability gap between the American Sherman and the German Panther had become a chasm that no amount of miracle weapon rhetoric could bridge. The 2,000-kilometer standard. The most staggering metric was the operational service life of the vehicles. Through exhaustive long-range testing, German engineers discovered that a standard M4 Sherman could travel over 2,000 kilometers, the distance from Berlin to the heart of the Soviet Union, before requiring any form of major mechanical overhaul. Its components didn't just meet specifications, they exceeded them with a massive safety margin that allowed for sustained high-speed road marches. By contrast, the Panther Ausf D, Germany's great hope, was a mechanical tragedy. An early model Panther was considered lucky if it survived 500 kilometers without a catastrophic failure. In many cases, the Panther's final drive, the complex set of gears that transmitted power to the tracks, would literally disintegrate within the first 150 kilometers of cross-country movement. For the German High Command, this meant that for every hour of combat, the Panther required 10 hours of intensive, expert maintenance. The Sherman, however, could be driven until the fuel ran dry, refueled, and driven again. Boutique craftsmanship versus industrial logic. The root of this disparity lay in the fundamental DNA of the two nations' industries. German tanks were what historians now call boutique weapons. They were built with a level of old-world craftsmanship that was beautiful to look at, but disastrous for total war. Each Panther or Tiger was almost hand-assembled by master smiths and specialized mechanics. This resulted in a lack of true interchangeability. Despite nominally being the same model, a Panther built at the ANN factory in Nuremberg might have subtle millimeter-level variations compared to one built at the Daimler-Benz plant in Berlin. In the field, this was a nightmare. If a German unit tried to scavenge a transmission from a knocked-out tank to fix another, they often found the parts required hours of filing and fitting just to mesh correctly. The Sherman, however, was a triumph of the American assembly line. Built by giants like General Motors, Ford, and Chrysler, every single part, from the smallest bolt to the entire engine block, was manufactured to rigorous, standardized tolerances. A Sherman crew in the middle of a Tunisian desert could pull a starter motor out of a crate shipped from Detroit and know with 100% certainty that it would bolt perfectly into their tank. This wasn't just mass production, it was industrial maturity. The statistics of disaster, Operation Citadel. The real-world consequences of this reliability gap were laid bare during Operation Citadel in July 1943, the massive German offensive at Kursk. On paper, the 200 Panthers deployed were supposed to be the steel fist that broke the Soviet line. The reality was a humiliation. 16% readiness. Within the first few days of the offensive, the operational readiness of the Panther units plummeted to a pathetic 16%. Self-destruction. More Panthers were lost to mechanical fires, seized engines, and shattered final drives than to Soviet anti-tank guns. By the end of 1943, as the Wehrmacht was being pushed back on all fronts, the disparity became a permanent feature of the war. While American armored divisions consistently maintained an 80 to 90% availability rate, meaning 9 of every 10 Shermans were ready to fight at any given moment, German panzer divisions were struggling to keep even 37% of their tanks combat ready. The German commanders faced a grim tactical reality. They could win a tank versus tank duel on Tuesday, but by Wednesday, their tanks would be broken down in a ditch, while the inferior Shermans would still be advancing, relentless and unbreakable. The War Daddy II had proved at Kummersdorf what the generals were now learning the hard way. In the theater of total war, a reliable, mediocre tank is worth 1,000 perfect ones that cannot move.
To truly understand why War Daddy II terrified the German engineers at Kummersdorf, one must look past the steel and oil and into the very fabric of the two societies that built these machines. The Sherman was not merely a weapon, it was the ultimate expression of a mature, decentralized automotive culture. In 1939, the United States was a nation on wheels. Thanks to the legacy of the Model T, almost every American family, regardless of class, owned, drove, and more importantly, repaired a car. In the United States, mechanical literacy was a birthright. A farm boy from Iowa or a factory worker from Detroit didn't need a military manual to understand the basics of an internal combustion engine, a spark plug, or a gearbox. They had been tinkering with them in barns and garages since they were children. When these men were drafted, they arrived at the front already pre-trained by civilian life. To them, the Sherman was just a very large, armored version of a heavy-duty truck. They treated it with a familiar, intuitive competence that the German military, a culture still largely reliant on horses and foot soldiers, could not replicate. The German automotive mirage. In stark contrast, Germany in the late 1930s was still an automotive infant. Despite the propaganda surrounding the Autobahn and the promise of the people's car, the Volkswagen, the reality was that motor vehicles remained luxury items, reserved for the wealthy, the Nazi Party elite, and the high-ranking officer corps. The average German soldier entered the war with a horse-drawn logistics train. When they were assigned to a panzer unit, they had to be taught mechanical principles from the ground up in rigid centralized schools. This created a technological caste system. In the Wehrmacht, a tank driver was a specialist who guarded his knowledge. In the U.S. Army, everyone from the commander to the cook likely knew how to jumpstart a Jeep or tighten a fan belt. This democratic mechanical intuition meant that Sherman units could perform field repairs in minutes that would have required a German unit to wait for a factory-trained technician. The collapse of the Reich's industrial precision. As the calendar turned to 1944, the structural flaws in Germany's boutique manufacturing philosophy were exacerbated by the fires of total war. The Allied strategic bombing campaign began to systematically dismantle the bottlenecks of German production. The death of the gearbox. In April 1944, a massive Allied raid targeted the ZF Friedrichshafen gearbox factory. In a single night, the production of heavy transmissions for the Panther and Tiger halted. The Maybach Inferno. Simultaneously, the Maybach engine plant, the sole source of V-12 engines for Germany's heavy tanks, was hammered into rubble. When production eventually resumed months later in improvised underground facilities, the precision that the German engineers prided themselves on had evaporated. With the male workforce bled white on the Eastern Front, the Reich turned to slave labor from the concentration camps to build their engines. The result was a wave of silent sabotage that no inspector could fully catch. Disgruntled, starving workers jammed cigarette filters into oil passages to cause engine seizures after 20 miles. They installed gaskets backwards to trigger slew leaks. They intentionally over-tightened bolts so they would snap under the vibration of combat. The American juggernaut. Thousands of miles away, the American arsenal of democracy operated in a different universe. Protected by two oceans, the factories of Chrysler, Ford, and Fisher Body ran 24 hours a day in perfect safety. The workers were not slaves, but well-paid, highly motivated men and women fueled by a seamless global supply chain. While the German engineer at Kummersdorf was struggling to find a specific grade of high-quality molybdenum for a Tiger's gears, the American designer was simply pulling standardized high-grade steel from an inexhaustible pile. The Sherman was the result of a reliability-first doctrine. Because the Americans knew their tanks had to be shipped across the Atlantic and operated thousands of miles from the factory, they built them with plug-and-play components. The War Daddy 2 was the ghost that haunted the German engineering boards. It represented a society where technology was a tool for the masses, not a secret for the elite. As the German industrial quality spiraled into chaos of sabotage and miracle prototypes, the Sherman remained a constant, a relentless, standardized, and unbreakable wave of steel that proved that a nation of drivers would always outlast a nation of craftsmen.
By the dawn of January 1945, the crisis of confidence that had begun with the capture of War Daddy 2 in the Tunisian dunes had metastasized into a total, irreversible systemic collapse. The German military-industrial complex was no longer just losing the war of attrition, it was cannibalizing its own soul. The high-ranking members of the Panzer Commission, meeting in the shadow of impending defeat, were presented with a dossier that read like a post-mortem of the German armored force. The warehouse of ghost tanks. The statistics were devastating. The report revealed a nightmare of incomplete production. Across the Reich, there were over 1,000 Panther and Tiger tanks sitting in factory warehouses and rail yards, massive, powerful machines that were technically brand new. However, they were functionally useless. They were missing their final drives. Because the German industry had prioritized complex, over-engineered gear systems that required rare alloys and extreme precision, the supply chain had snapped. The tanks were paper tigers. They had the guns to destroy anything the Allies fielded and the armor to shrug off most hits, but they lacked the basic mechanical reliability to move 10 miles to the front lines. The Third Reich had spent its last remaining resources building monuments to technical vanity that couldn't even roll off their own assembly lines. The psychological shattering. The technical failure led to a far more dangerous phenomenon, the total evaporation of the soldiers' morale. General Wolfgang Tomali, a man of cold logic and chief of staff to the Inspector General of Armored Troops, was forced to admit the bitter, unvarnished truth to the high command. He observed that the myth of German technical superiority had died in the hearts of the men in the mud. Tomali's report was haunting. The troops have lost confidence. He described a terrifying trend where German tank crews,
faced with the slightest mechanical hiccup or a minor transmission noise, would simply spike their own guns and abandon their vehicles. The fear wasn't of the enemy's firepower, but of their own machine's fragility. The crews lived in a state of constant, paralyzing anxiety, fearing that their invincible Tiger or Panther would become a 60-ton steel coffin the moment it tried to maneuver in a retreat. They looked at the advancing Shermans, tanks that never seemed to stop, never seemed to stall, and were always there, and realized they were fighting a ghost that couldn't be killed by a 75mm shell. The final stand, the ghost of War Daddy 2. In the final desperate weeks of April 1945, as the Soviet Red Army encircled the ruins of Berlin, the irony of the war reached its peak. The high-tech proving grounds at Kummersdorf were evacuated, but the Butte Panzers, the captured Allied tanks that had spent years being poked and prodded, were not destroyed. In a fit of suicidal desperation, the remaining staff at Kummersdorf formed an improvised combat unit. They took the very tanks they had used to study German failure and turned them toward the advancing Soviet T-34s. Among them was War Daddy 2. The Sherman, which had survived the deserts of North Africa and years of brutal torture testing at the hands of German engineers, was fueled one last time. It was an incredible testament to its design. After years of being disassembled and pushed to its mechanical limits by the Reich's best scientists, it still started, it still moved, it still fought. The captured Shermans were pressed into the defense of the approaches to the capital, fighting alongside the few remaining stuttering Panthers. They fought with a reliability that their German counterparts could only envy. War Daddy 2 and its brothers in arms did not fall because of mechanical failure. They fought until their ammunition racks were empty, until their fuel tanks were bone dry, or until they were finally overwhelmed by the sheer crushing weight of Soviet numbers. When the dust finally settled over the blackened husk of War Daddy 2 in the outskirts of Berlin, it marked the end of an era. The tank had arrived as a prize of war to prove German superiority, but it died having proven the exact opposite, that in the brutal, mathematical reality of modern conflict, the machine that reaches the battlefield is the only one that matters.
The saga of War Daddy 2 and its exhaustive dissection at Kummersdorf is far more than a footnote in the history of the North African campaign. It is a cautionary tale about the dangers of technical hubris and the deceptive allure of perfect engineering. For decades, popular history has framed the Sherman as a sacrifice tank, a vehicle that only won because 5 of them were sent to die against every one Tiger. But the dusty, blood-stained reports hidden in the Kummersdorf Arpacketsmine tell a different story. They revealed that the Sherman didn't just win through the quantity of its production, but through the quality of its philosophy. The paradigm shift. The German engineers who crawled through the hull of Beutepanzer 259 were the first to realize a terrifying truth. America hadn't just built a good enough tank, they had mastered the logistical dimension of war. They understood that a tank is not just a weapon, but a link in a massive, thousands of miles long chain. If that link breaks because of a fragile gear or a temperamental engine, the entire chain fails, no matter how thick the armor or how powerful the gun. This realization would lay dormant in the German psyche for a decade, only to resurface when the nation was allowed to rearm during the Cold War. When the engineers of West Germany sat down in the 1950s to design the Leopard 1, they faced a choice. They could look back to the Tiger, the complex, heavy, and terrifying legend of their past, or they could look to the lessons of the Sherman. They chose the Sherman. The Leopard 1 became the ultimate Sherman philosophy tank for the modern era. The German designers abandoned the pursuit of impenetrable armor and boutique complexity. Instead, they prioritized exactly what War Daddy 2 had demonstrated in 1943. A robust, overbuilt powertrain, a motor and transmission designed with massive safety margins so they would never be pushed to the point of catastrophic failure. Ease of maintenance, a modular design where the entire engine and transmission could be swapped out in the field in under 20 minutes, a direct evolution of the American plug-and-play concept. Standardization, a rejection of handcrafted parts in favor of industrial uniformity that ensured every Leopard in the fleet was as reliable as the last. The hard truth of engineering. The Sherman proved that a weapon's true lethality is a product of its availability. A tank that is sitting in a repair depot 20 kilometers behind the lines is effectively a zero on the battlefield, no matter what its technical specifications say. A Sherman that is rattling toward the enemy, day after day, week after week, with an average gun is infinitely more lethal than a perfect Panther that has seized its engine in a muddy ditch.
War Daddy 2 was the messenger of a reality that the Third Reich was too arrogant to accept until it was too late. Germany had not just been outproduced by the factories of Detroit, they had been out-engineered by a society that understood the brutal, unglamorous mathematics of total war. As we look back at the charred ruins of the Kummersdorf proving grounds, the legacy of that single captured M4A1 remains clear. It stands a monument to the idea that in the grand theater of history, complexity is a luxury, but reliability is a necessity. The Sherman didn't just win the war, it redefined what a successful war machine actually looks like, proving forever that the most dangerous weapon on the battlefield is the one that actually shows up to the fight.